So hello everybody, and you're very welcome to the Zero In webinar. My name is Colin Fitzpatrick, and I'm from the University of Limerick in Ireland. And over the next 4 or 5 minutes, I'm going to give you an overview of two work packages from the Zero In project. The first is work package 2, entitled Innovative Technologies for Individual Producer Responsibility and Product Reuse, and work package 3 on waste prevention methodologies and strategies. So in this, what I call like a whistle-stop tour of the two work packages, the main topics I'm going to look at will be how RFID technology can play a role in industrial networks and what testing we did to show that, and also then some technology concepts for reuse to show how different technologies could actually facilitate more reuse within industrial networks. In work package 3, then, we take a step back and we take a look at design and how we can actually design products such that they can both facilitate the use of materials from industrial networks, but also then produce materials that when they're completed that are useful for other partners within an industrial network. So first of all, on work package 2, I have to introduce what is RFID technology. RFID technology is a means of wirelessly transmitting information that's stored on a chip that's typically then integrated into a tag. In many cases, it's regarded as like a barcode that does not require line of sight and can have multiple reads simultaneously. Previously, RFID technology has had a lot of problems in many applications, because it had been unsuitable for use in the presence of metals, and also liquids caused problems with reads, and plus the orientation tags previously would have to have been lined up quite closely with the reader to get a read. In recent times, there's been significant development in RFID, particularly with their use around metals. So for this project, what was novel is that we began to look at how these newly designed mount on metal tags could actually be used on the types of sectors that are of interest to Zero In. We chose 3 tags in particular. You can see them at the bottom of your screen. Different costs, different dimensions, but all exhibiting very good read rates and performances on metals. So with that, then we also used a lot of RFID equipment and readers and different types of readers in order to do our testing to see if RFID could be used to work in industrial networks. We used this at a range of different frequencies, focused in on the UHF frequency, and had 2 fixed RFID reader kits and 1 handheld RFID reader to simulate the different environments that may exist in waste and in byproduct environments. So we examined the subject sector by sector. Again, I only have time today to show you a very brief number of the experiments, but here's an example of some of the different ways we tested the use of RFID tags for the electronic sector. We did it in office environments, in take-back environments, in industrial environments, and each of the cases we managed to achieve very, very high read rates, which were higher than anything that had been achieved or published previously. We studied this on PV panels. Again, you can see here the student involved in the testing. Different rates, or different distances and different setups, and in this case you can see a handheld reader being used. We also did it for the automotive sector. You can see we've done 2 different types of tests. One where we pick a specific part of the car and we inventory all of the components with using RFID, and secondly where we pick the car in its entirety, and again to inventory what are the components or what are the materials that are available. Again, receiving excellent read rates. And lastly, then, in the construction sector. So the construction sector is obviously quite different than our previous 3 sectors, which involve tangible products. The construction sector is quite different in that a building is a very different type of outcome. And in this case, we came up with a different situation whereby we would use RFID and GPS and GSM networks to actually track and trace waste movement and to make that waste visible to the resource exchange platform. So in this case, we had tags placed on the skips into which waste materials could actually be placed. This waste then could be uploaded onto the resource exchange platform, whereby different people could see it and then direct the truck where it should actually bring the waste and direct the truck onto the next user for the material. Again, this is an example. Just a photograph of some of the experiments and the tagging and the tracking of the truck. So one area where we feel that is necessary, the last piece in the jigsaw before RFID can really become mainstream in the use of for industrial networks, is in standardization of information sharing between businesses. On this graph here, you see I've called this discovery services. This is where businesses without a prior existing relationship can share information from their databases, particularly for aspects of importance or relevance about the material that is to be shared. Okay, so moving on then to look at the technology concepts for reuse. Today I'm going to share with you two examples of this. Again, there's much more comprehensive information contained within the actual report. This example here is the use of sensors in order to measure performance of products or equipment and how they have been treated during their first life, in order to provide information about reliability and to give security to the next user of the material, that they can be sure about how it has been used. You see on the left of this slide, you see an example of the technology that was developed to record and store information about how something's been used. For example, it could be monitoring temperature, it could be monitoring vibration, it could be monitoring humidity. Basically, any parameters that would be of interest to know what type of reliability issues may be associated with a product or with a material that's going to be subsequently used in a new product. On the right, then you see an example of how this has been integrated into a piece of industrial machinery, such that at end of life people would understand more about the structural integrity of the materials. The second concept we explored here on for reuse was to look at what type of sensors are already integrated into products. Most products, particularly high-tech products today, have a lot of sensors already in them just for the normal operation of the product. An example of this would be in a computer or a laptop, where the fans are being controlled by temperature sensors. Basically, if the temperature goes up on the product, the fan needs to switch on in order to cool. So what we've done is we've managed to find ways of logging this information and sorting it and storing it and identifying basically usage patterns around the product, such that when these products come to end of life, it's again very easy to know how they've been treated, how many hours in operation they've had, have they been used extremely intensively, for applications that require a lot of processing, or have they just been used for very, very simple and basic types of operations. Again, our concept is that as the product came back, these outputs could be read using an RFID reader. This information is immediately placed to the resource exchange platform, where it becomes available then to other industrial network members who may wish to use this equipment. Okay, moving along to work package 3. Work package 3 was on design and how we could design products for industrial networks designed for waste reduction. We had a very detailed investigation of all of these D4R trade-offs. Some of the examples here are designed for minimized production waste, designed for production waste recycling, designed for lifetime extension, repair, reuse, disassembly, depollution, material recycling, and design in recycled materials. Again, I don't have time today to go through each of these for each of the individual sectors specifically, but I can talk a little bit about the D4R laptop that was developed and how the Methodologies employed in Work Package 3 help to create the products that you can see in another webinar. Basically, the product needed to be designed such that it could receive material from the industrial network. And one of the areas of concern for producers in using industrial networks is they need to know that they can get a consistency of material arriving through just as they need it for their production processes. So one of the concepts that emerged from Work Package 3 was the idea of a product that had enough flexibility and resilience in its design such that it could receive slightly different specified materials. So the idea of the universal motherboard came from this, such that a motherboard that could actually receive different types of processors, different types of memories, slightly different specifications of screen, so that the design was sympathetic enough to compensate for the slight variations that an industrial network could supply as opposed to a traditional supply chain. Another very simple example we've shown here is about the development of the frame or the casing, about how different design ideas can reduce the waste. So we see here a classic example of where you have a rectangle of material, you need to make a frame from it. You cut the rectangle out from the center of it, and that creates waste. Whereby a slightly different design, whereby the frame is constructed from 4 separate pieces, means that the waste is eliminated in the first place. And again, this is a very useful concept for the D4R laptop. It's also very important to explore what are the good recycling practices. So, if we're going to design products that can be used as part of industrial networks, we need to know what happens to them at end of life and how can we design the product such that it delivers material that is of use to other industrial network members. So here again, we see there was very detailed work undertaken to explore what are the practices that these products undergo at end of life, and what are the different design criteria that we could include in the product at the start, such that it facilitates high quality material delivery. There was also innovative product evaluations undertaken. This is here an example for the reuse computer evaluation. Again, there are no agreed criteria on what makes for good reuse. So this was developed after a prototype of the product was delivered, such that it would give feedback from an experienced recycler, from an experienced refurbisher and reuser, back to the manufacturer how they could integrate changes into their design to make the life of the next user easier. And again, this is a wonderful example of whole system thinking, feeding back from different levels in the cycle of how you can improve things. This is also undertaken with the photovoltaic sector, in addition to the construction automotive. I'm going to finish with this slide here from the photovoltaic sector. Again, very, very interesting type of products with very, very long lifetime, and products that there is not yet very large amounts being returned. So again, there was very good research undertaken on how the design of these products could be taken place to allow for the easy separation of materials at end of life. And for the power conditioning equipment, how could it be developed such that it would be useful for the next user within the industrial network? Okay, so I've come to the end of my presentation. I'd like to thank you for your attention. If you've been interested in anything I have to say, you can get in contact through the ZeroWin website, or also you can see our ZeroWin deliverable. Okay, have a good day.